5.1, question 4. What is the income distribution of super shoppers? Right, a supermarket super shopper is defined as a shopper for whom at least 70% of the items purchased were on sale or purchased with a coupon. Those are apparently supermarket super shoppers. Now, in the following table, income units are in thousands of dollars, and each interval goes up to but does not include the given high value. The midpoints are given to the nearest thousands. All right, so you have an income range from 5,000 to 15,000, but it doesn't count the 15,000. Then it goes from 15,000 is included up to but not including 25,000, and so on. Then the midpoint, all right, what's the midpoint of 5 to 15? $10,000, $20,000, and so on. Then you have the percent of super shoppers. So if the midpoint is 10,000, 20% of super shoppers are in that group. If the midpoint of the income range is 20,000, 13% in that group. And then finally, if you get all the way over, if the midpoint of the income is 60,000 or more, well, then the percent of super shoppers is 10%. So what are we being asked here in A? Use the income midpoints and the percent of super shoppers. Using those, do we have a valid probability distribution? All right, now all I'm going to do is I'm not going to write the whole thing up, but I do know this, right? We do know that, first of all, for each x, this has to be true. All those values have to be between 0 and 1. And the second thing that has to happen is that if you add those p of x's up, you have to get 1. All right, so let's look at these. Now, what we're being asked in part A is to do this. Using the income midpoints, right, using these x values here, and the percent of super shoppers, those are the red numbers, do we have a valid probability distribution? Well, to be a valid distribution, two criteria, right? For every x, the p of x's, the red numbers, have to be between 0 and 1. And then when you add up those p of x's, add up the red numbers, you have to get 1. Well, by observation, I can see that for every one of these midpoints, every one of those black numbers, the percents are between, the red numbers are between 0 and 1. So this first condition is met. Now what about the second condition? Do they add up to 1? So what do we get here? 20 and 13 is 33. 33 and 21, 54, 71, 81, and 19, that's 1. Yeah, so that condition is held too. All right, so our answer is yes. So we can get rid of all the no's, first of all. So I can get rid of that one, I can get rid of that one. Now what yeses do we need to get here? Let's say yes, the events are indistinct. They're not indistinct. There's no overlap here, so that one's out. Yes, the events are distinct and the probabilities do not sum to 1. That's not true. Yes, the events are distinct and the probabilities add up to 1. Now, by distinct, they mean like if you pick any midpoint here, super shopper is not going to be in one category and the other. All right, so we are going to get that as our selection. Now, B, which one of these histograms, this one, this one, this one, or this one, do we think matches our data? Well, look, at 10, we're at 20. At 10, we're at 20. Just match them up. Actually, it's a little bit more, right? It's a little bit more. And this one down here is a little bit less. So I think I'm going to rule out these two. What about over here? At 10, this one's at 10. At 10, this one's at 20. This is the only one that works for this one. Just check another one. What's the next one? The next one's at 20. We should be at 13. So I'm at 20 and 13. Looks like we're good here. So I'm gonna choose this one, which is this one right here. Now, part C, they're asking for the expected value. We know how to get that. That's going to be the sum of the x times p of x. Now, I'm going to write it out here, and then we'll just do it on our calculator. So if I was doing it all by pencil, it would be x, the x value, which is the midpoint. Oh, not x. Okay, so what is x actually here? It's 10 times the corresponding probability, 0.20. plus, and then it'd be 20 times that probability, 0.13, plus 30 times that probability, which is 0.21. All right, now let me get rid of some of that junk. Do you see where I'm going here? 10 times the 0.20. I'm going up here, I'm taking the x, 10, and the probability, 0.20, plus 20 times 0.13, 30 plus times 0.21. All right, I'll just finish it off here. Then it's going to be plus, where do we leave off at? 40 times 0.17 plus 50 times 0.19, finally plus 60 times 0.10. Okay, so we could do all that arithmetic and come up with some number. But let's do it on our calculator just to be sure that we know how to use our calculators. So go to Stat, S-T-A-T, go to Stat, press your Stat key. All right, turn mine back on, press Stat. Now, number one, all right, choose number one, which is Edit, because we're going to put data in. So you choose number one. Now, you might have numbers in there from the previous problem. So L1 and L2. So now you have to get those numbers out. So I'm just going to talk your way through this, talk our way through it. Put the cursor right here. Get the cursor in L1. Your cursor's in L1. Now, bring it all the way to the top. Use the up arrow, get it all the way to the top. I'll do it too here. All the way to the top. So that L1 is highlighted. Now press clear over to the rightmost column by the arrow key. Clear and enter. All that data disappears. Now, right arrow over to L2. Get cursor in the second list. Up arrow so that L2 is highlighted. Press clear and enter. All that data is gone. Now, arrow back over here. Arrow back over here. And put these numbers in. Now, there's not that many, so what are we going to have? We're going to have 10, enter, 20, enter, 30, enter, 40, enter, 50, enter, 60, enter. Right arrow. Now we'll put in those probabilities. 0.2, you can put in 20 if you want. You don't need that other 0. 0.13, 0.21, 0.17, 0.19, and 0.10, or just 0.1. Now we've got all those in. Go back to the Stat key. So go back to your Stat key, over to Calc. We're ready to calculate now. So over to Calc, and choose number one. One variable statistics, one variable stat. So you choose that one. And now what you want is, all right, you have list, frequency, and then you have calculate. Now this list, you want that to be L1, and you want this to be L2. So here's how you get them. You need to actually just put those names in, L1 and L2. So here's how you get it. I'll do it down very at the bottom. You press the second key, and then you press the numerical key 1, because right above the 1 is L1. So press second and 1, and then L1 pops up there. Press enter. Now press second, L2, or actually the number 2, because that's where list 2 is, and L2 pops in there. Now enter, go down to calculate, and press enter again. Now here's what comes up. The top number I'm getting is X bar, which turns out to be the expected value. All right, so the expected value is 33.2. There's our expected value. And the standard deviation, that's going to be sigma of X. Now you can't put in S of X, right? It's blank. There's nothing there because the calculator knows it's a probability distribution because you're putting in decimals. So this turns out to, now it says to round to 2 decimal places, so I'm getting 16.30. 16.30. I'll enter these numbers here at the bottom left. Compute the expected income, 33.2. So the expected income, just pick a super shopper at random. What do you expect their income to be? About 33.2 thousand. Compute the standard deviation. Standard deviation is 16.30 to 2 decimal places.